Well, welcome everyone to today's webinar, which is focused on the Police Data Initiative and how one can manage this and what some of the benefits are and what some of the issues are. We're joined today by a couple of guests. I'll introduce myself first. My name is Dale Lutz. I'm one of the founders of Safe Software.
And I'm Kat Gracie. I'm an account manager at Safe Software for state and local government, and in that deal with a lot of local police.
And on the phone we have Robert Schulz from the RCMP in Canada. Robert, are you there?
Yes, I'm here.
And also Alice Pence, and she's from the City of Auburn. Alice, are you still there?
Yep, I'm still here.
Great. So Robert and Alice are going to tell us in more detail some of the initiatives they've been involved in and some of the issues they've bumped into. But just by way of introduction, I thought I would just say we make software that moves data from wherever it is to wherever it needs to be, and it lets our customers do that easily and without needing to write any code. And so when we talk about open data or publishing data, very often the problem comes down to getting the data from wherever it is within an organization to the portal where it's going to be published, and very importantly along that way transforming it to throw away some information, perhaps anonymizing it, or more importantly doing some quality assurance. And lastly, we realize that once data moves, you probably want to keep it flowing, so the importance of automating that, having it happen on a regular basis or in reaction to events, are things that we think need to be done, and we try to provide value by giving tools that do these things. So it's not surprising that given our tool set, we have many customers around the world that use these tools to publish data related to police activity, related to operation of government in general, and so that's what we're going to be talking about today. So I had an email arrive in my inbox about a month ago. At first I thought it was not real. It was from the White House inviting me to come to a special initiative meeting that would have a number of U.S. police jurisdictions there talking about an initiative to exchange and publish, make available police data to the public. But it was for real, and so I did make a trip to Washington and had a really interesting day. It was probably the safest place I've ever been. I was inside the White House surrounded by chiefs of police. So, but I was the token Canadian there, and I had to wear a special tag. It was actually a purple tag, which was significant because it was also the day Prince passed away. Oh. So I felt very special that day. But they reported on a number of the progresses that have been made in the 1 year of life of the Police Data Initiative. And if anybody's interested, maybe Stephanie, you can chat out that link to the Public Safety Data Portal, where the data that's been published during this time can be obtained. This was the snapshot of the progress at that point. At that meeting, a number of other jurisdictions signed up to add data sets to the initiative, and so that number is going to continue to grow as the year and the initiative progresses. But the reason that I think we're here today, but also that I really took away from that meeting that day, was kind of an answer to the question of why. Why should police data specifically be shared? And there's various, when we talk about police data, there's a wide range of police data, but in general, the concept is that sharing data, making it available, increases transparency and builds trust between both the police and the citizens they serve. Secondarily, this can help provide improved services and ultimately fuel better decisions. It also helps the public see what's going on and can help them to make better decisions as well. But there are a number of interesting issues when you talk about sharing police data. You don't want to be publishing specific details many times. You need to protect the identities of those involved. You need to make sure you're not sharing things that it's against the law to share. And you need to make sure that the data is as accurate as possible. And these are some of the issues that are faced when these initiatives are undertaken. But from that day at the White House, there was one talk that really drove home the potential value of doing this. And that was given by David Brown, who's the 6-year police chief of the Dallas Police Department. And he said that transparency efforts there have played a key role in engaging the public, and he had numbers to back it up. So As part of their efforts, they released 12 years worth of officer-involved shooting data, including information like the race and the race of the subject and the officer. And that was made available in easy-to-read format. So not just a scary PDF that can't be parsed. You know, some people say in our industry that PDF is where data goes to die. So that is not generally a good format. So this was made available in Excel spreadsheets, CSVs, and so on. And the result, or at least what ended up happening, was that there was a 45% reduction in the deadly force incidents in Dallas in 2015 compared to the years previous. Now that is shocking number, and a 67% reduction in excessive force complaints. So those are two very significant numbers. I know there's going to be master's students doing their thesis to try to dig into what is the cause and what is the effect, but nonetheless, it doesn't seem disconnected that a big initiative to release police data had at least some role in changing the tune of the situation on the ground in Dallas, and so that was a great success. So, with that as kind of background as to the why, I thought we would start with Alice from the City of Auburn to tell us what she's been up to. So Alice is a GIS and database specialist at the city, and she is the project manager for citywide GIS web development applications. Her responsibilities include creating and maintaining data management protocols, and she's also the lead for aerial imagery and LiDAR acquisition analysis. Alice holds a BSc in geography from the University of Idaho, and she's been in the GIS field for 3 years and at Auburn for over a year now. So Alice, we'll get Stephanie to give you the helm here, and you can tell us what you've been up to with respect to sharing data.
Awesome, thank you. Make sure that everybody can see my screen, right?
Yep.
Okay, so yeah, in the City of Auburn, I was tasked with the great one of trying to get how to get all of our crime data and import it into GIS, and I will go through all the details on how I've actually managed this stuff. Like Dale said, a quick bio, I got my geography degree from the University of Idaho. I have a certificate in GIS. I've been in GIS for about 3 years now, and then I've been with Auburn for about 1.5 years. And so this is kind of the breakdown of our crimes database. It's stored in a Linux system. It's raw. It's basically straight from the field and from the office that the police department puts in. And so it's complicated. It's not clean. It needs to be QA'd, QC'd. It needs a lot of stuff before it's accessible and available to the public. And it's right from a Linux system. And from a GIS background, I didn't quite know what I needed to do to try to get it to where I needed it to make it public facing. And so basically that was my first reaction, my first impression. How to take all this data that's not clean, it's in a Linux-based system that's really hard to pull data out, and then get it public facing. So basically this was our mission. And we had a lot of ideas flowing, you know, couldn't think of anything, but we're like, oh, let's try with at least one stub. So we tried with the Python script first. And like it kind of outlined on the script, there's the good, the bad, and the ugly about Python script. I mean, we got it to work. We got able to change offense names. We got the geocoder to work. I put it in Windows Scheduler to make it to automate it. But basically, when I go into more details about the crimes database, it's a very long, cumbersome script. There's so many different crime types that I had to categorize and update, and so it ends up being pages and pages and pages long. And basically, to make it work, I needed multiple databases and had to pull it out of the database, put it in a geo database, move it to another database to clean, back to the SDE to get ready to go. And then crime data for us updates a lot. Sometimes the chiefs will call and say, hey, I want this to be shown on the map. And so I had to go into the script, update it, find what I needed, then export it out, and then just do all this different kinds of stuff just to get it updated. And there's no custom alerts or in-depth logging capabilities, so if it failed, I just had to kind of go through and see what failed, what time it failed, and just kind of did my best to guesstimate. And then if I wasn't here and somebody else needed to do it, it was not user-friendly. Everybody else kind of had to do the same thing that I was doing. It was poke around, try to find it, and figure out why it's not working. So we figured that had to be an easier solution. And so we came up with the next idea, and it was FME to the rescue. So basically, I was able to connect to our database. Like I said, it's in a Linux-based system, connected to it easily, was able to update the crime types, crime names, rename attributes easily, change dates, and geocode simply on the fly. And you can see that from here on my screenshot of my FME script. So the first challenge, like I was saying, is those offense names and those offense codes. And then, like I said, the Python script was really, really super long because there's so many, and you had to group them by multiple types and then go in and change if it's like null, if it's not null, if like we don't need to show it, I have to put a different symbol on there if we're not going to show it. But then if you look on the FME side, it's just 3 simple transformers to get rid of the nulls, change the offense types, and the offense names. And the attribute mapper became my best friend for this. I was able to bring in all the different crime types, label them, and it was from a CSV file, so I just said import CSV, and it was there, and I just point to it. So now if I need to update, like as an example, the RKBK crime type is a crime type, felony crimes against person, crime name is a robbery. I can just simply go into attribute mapper, try to find those 4-digit codes. It's all alphabetical anyway, so it's really easy to find. Update it, hit save, and then the script's already updated and ready to go. And this is the rest of the process, basically how I get it into GIS. I rename a few of the feature fields for how we have it viewing in GIS. I add a date formatter, so it's more of a standardized dates. And I use the free Google Geocoder. Pretty simple, uses the addresses, city, state, zip. And then that's a view of my ArcGIS catalog, and there's all the crimes that are geocoded and put on the map. And so this is kind of like the rest of the process on how I actually get it up to the web map. And it's simple. It's just the FME script right to my SDE database. I put it in my MXD, use a symbology. I kind of put some filters on it, so like crimes last 3 days, crimes last 30 days. Push it up to my ArcGIS server, and then when my web apps read it. And so then everybody can do analysis and click on points and run reports and do everything off of that. And then the best thing, there's still more with FME, which is awesome, is how to automate it and also try to find all my logging. And so FME server was great. All I did was upload the FME Workbench to the server, just said I wanted every night at 6 o'clock, I needed this to be updated. And it just basically grabs all the new crimes that were in that night, updates it, and then I get email notifications if the Workbench succeeded or failed. And then it will tell me like, oh, this is the job number. So then I can easily go back into FME server, find the job, and then be able to see if it's like where it failed out easily. And then that goes to here where it's beautiful, it's the logs, and it puts out every single thing that happened. So then I can see, oh, that one failed, go to the log and see exactly what time it failed at, what failed, and then I can easily go back and try to figure out what happened. And so that's the main point. FME Rocks has definitely helped me out with getting rid of Python and make our system quicker, simple, and get all the crime data that we needed out. And so just like a quick comparison, like I said, the Python, like it worked, it was great, but it was not user-friendly is the main point. It was long and it's hard to update. FME, easy to update, easy to change codes, and I can share directly to FME server, and then also it's user-friendly. So I can actually write quick little notes if I'm not here and someone needs to update and see why it failed, they can go in FME server and find exactly what happened. And then it still gets better. We're actually using our crimes database with Socrata Open Data Portal that we just launched. And so this is kind of our main page of our Open Data Portal. And as you can see, the police symbol is right there. So we're uploading all of our crimes data nightly, and it's from the same database and everything to our Open Data Portal through Socrata, so people can access it from there. The FME Workbench is a little bit more in detail because Socrata needed specific location fields and the addresses needed to be cleaned up exactly per those location fields. But basically it's the same steps. I go through, do all the, get rid of the nulls, get rid of and add offense types, offense names, rename, sends it all the way through, and then search by addresses. I have some string searchers in there to make sure everything is clean, ready to go for the specific Socrata location field, sends it up, right to our Socrata database every night. So people can go in here and they can do API downloads, export tools. You can connect directly to this if you have a live app. We've made custom data lenses, or better known as graphs and maps, and people can see, just click on the fly, different reporting, tools and offense names. There's even more. Like, this is just the kind of the basic outline of what we've done so far. And I mean, the potential is growing for what we can do to show our crimes data. And I've left on this last page some of the links so people can check out our open data portal and also what our crimes maps looks like. So back to you guys.
Well, thanks so much, Alice. I'm going to ask a couple of questions, and if any of you have questions, please type them in. Oh, already one person has asked, Alice, how do you manage and detect changes? How is that part of the process being done?
Like changes in the different crime types?
Yes.
Yeah, basically we kind of have like the standard fields now and everything, and actually I've set it up within the script. I probably could have shown it too, where if it's something that I haven't categorized yet, or if it's not a null, it actually will log it for me, and if there's a crime type that I haven't categorized yet, it actually pulls it out and shows me that this one, went through the script. You need to categorize this one or put it to a null, and so I'm actually able to see that before it's completely published. And so I can catch it and then go back to, I can call the chief and say, hey, this is a different crime type. Do you want me to show this on the public site? And then he's kind of the one that says yes or no, and then I can quickly change it.
Alice, are you in a position to show us like how I know that when we were practicing, you had a list there of the codes that are kind of to be published and aren't. If we give you back control, do you have that workspace handy that you could pop that up and show folks?
Yeah, let me pull it up here real quick and then...
And I think that part of your ingredient is that you're doing a query to only get the stuff that changed since the previous day. Is that right, Alice?
Right. So when you go in here, I have
yes.
a SQL statement, and I was just testing it yesterday. So mostly it just says system date -1. So when it runs, it's pulling the new ones that were basically in the DT, REPOR, that's the dates. And so I'm basically querying against the dates that were yesterday and then just appends to my database.
Yep.
And then
right. This is where the secret sauce is, right in here.
Yeah. So this is like I said, my favorite transformer. And like I said, all I did was import from source and destination values, and so I just had a CSV of all of these. Yeah. And then I was able to import them just as an initial dump. And then now I can just go in here, change the source value, change the destination value. And like I said, there's some of these that have the symbol, and those are just the ones we don't want to show, but they're still in there, and I can quickly change to whatever kind of offense type this is.
Right, so that's one of the key things. So where there's a dash, that means you're not going to be publishing that in some way.
Correct.
Yeah. And so that's a key
to filter by. So.
Yeah. Awesome. And one thing I'll just mention is that some of our customers do exactly this kind of thing, but they store this table we're looking at here in an Excel spreadsheet, and then there's a transformer called the joiner that can pick that up at runtime, and that way the spreadsheet can even be maintained by non-FME people. Right. Yeah. So are there any other data quality things that you do inside of this? I know you check for nulls. So that must be for stuff that isn't all the way filled out?
Correct. So basically, nature is the attribute that has all the crime types and everything. And basically, I just say if it's empty, like because sometimes the table updates during the night, like if they've had like an officer is typing it in, but they don't know what the final crime type is, they leave that blank. And so the initial night when it goes through, I might not pick that up, and then they would change it, but then it would change the next day, then I'll be able to pick it up. But just so we don't have any empty attributes showing, I just change it to this symbol right here, so it can just show up as a dash, and then I can change that later too. Yeah, yeah.
One other thing that some customers do is use a FME transformer called the change detector, which in your case you have good date stamps on your source data, and so you're basically, because you can use that SQL statement, your database that you're coming from is helping you track, or is doing the work of tracking what's new. Some customers don't have that, and in that scenario they basically read the whole thing, compare it to the whole thing from the day before using a change detector transformer, and then the stuff that comes out of that tells them what's new and what needs to be changed and updated in their output database. Lastly, I was going to ask you, right today, you look like you're updating, or you have this running, both going to an SDE for your web map as well as the Socrata. So you've basically got two streams of this going from the same input. Is that right?
Yeah, I mean, like I said, the Socrata was a little bit more pickier on the address field, so that's why I have two separate ones. And then they're going to just to different, I mean, this is just, yeah, we'll go to the SDE, and then the Socrata one goes up to the Socrata data set table.
Yeah, yeah. So someone has asked if there's an update detector. I think that, I can't remember in FME if we've got two transformers. One's a change detector and one is, boy, I'm rusty.
You're looking at me like
yeah,
I know.
I don't know what the other one is, but there are two. If there is a key in the original data, like if there's some unique key, we can tell if it's been modified. So yeah, Bruce Harold has chimed in and said that's the matcher. That's sort of like that. So there's a change detector and a matcher that are probably the ones to look at. Another person has asked, so FME is like an ETL tool, but for GIS data. Yes, we used to call ourselves the spatial ETL experts. So really we are, and as such we can work with lots of different formats. In your case, Alice, what is the actual database on Linux called?
I actually have no idea. All I know is just all he told me was it's proprietary Linux, and like I said, the only way I was able to get to it was an ODBC connection, and so I just found the tables in there and then was able to connect. So
that's awesome. So another person has asked that API download you showed from the Socrata side, is that all just out of the box Socrata, or did you have to do a bunch of work to set that up?
That was out of the box.
Right. So once you become a Socrata subscriber, then all of that comes for free. And,
yep, and then
I know
you can
that
customize it. So.
Right, because there's a number of different formats on there. I know there's JSON and a few other things too. So there wasn't any.
I actually have it up here. I can pull it up so people can see it. And like I said, this is all open. We can send the links out later for you guys to see. But yeah, I mean, there's definitely, you can filter, download, export. There's APIs, and then all the different download capabilities.
And look, there even is PDF for those that want to put that data to death. They can get it as PDF. But normally people would do that. But that is, so Linda was asking about that, but that is really all handled by Socrata. And I mean, to be fair, there are other systems too. We did a webinar that we'll be tweeting out at the end where we looked at 9 different open data ones. I know Esri has with ArcGIS Online an open data thing as well, but Socrata certainly has been taking the lead in this particular area. Someone is asking why there doesn't seem to be a map, but I think you do, Alice, you do make a map out of this stuff in Socrata as well, is there?
Yeah, so that's, we can customize on our end also what we want people to see, like the maps and everything. But also, when people log in, they can make their own maps.
Okay.
So, like that data set table that I showed, you can actually hit, visualize, and then you can say, I want to visualize by crime type, and then so you can build your own view, basically.
Okay.
But on our end, we built kind of like a basic data lens, and so like we have the map right here, and so people can kind of use one that we custom built for them, or like I said, you can use the view as and build your own map.
Okay. Oh, there's other mapping options as well.
Yes.
Okay. Yeah, I think that's what Scott was getting at, and so it's all. Okay. So Scott is okay. He's happy with your answer, but there is. That's great. So thanks, Scott, for asking about that. I didn't know about that either. So there are, Socrata has different options there. So I think Alice, thanks so much. I think. You've been great in answering some of these things, and please do hang around. We'll open it up at the end of the whole webinar in case people think of other questions to stump us with. But I think with that, so we did some Q&A, and that's always, I find that the most exciting part. So that was great. Thanks so much for being a good sport there, Alice, and that's great. Now we're going to switch to Robert, who's from the Royal Canadian Mounted Police, which sounds very colonial, doesn't it?
That is formal.
And I like to say that for those that don't know, one of the famous slogans of the Mounties is that they always get their man. But in this case, Robert's going to tell us how they always forget their man. So Robert has been the geomatics coordinator of the RCMP Information Management and Technology branch for 11 years. And he and his team provide a wide variety of GIS support services, including project management, application development, geodatabase design, spatial analysis, and map production. Robert holds a BSc in Earth Science from University of Victoria and an advanced diploma in GIS from BCIT, and has been working in this field for just over 15 years. And I also found it interesting, Robert, that you're an instructor at BCIT's Forensic Science and Technology program, and I'm sure that that's got to be an interesting topic to be involved in.
Yeah, I teach a introduction to crime mapping.
Cool. So with that, Stephanie, let's hand it off to Robert, and he'll tell us about some of the work that he's been doing over the past while.
Should be seeing the City of Nanaimo's crime map.
You bet.
All right, good. Well, thanks, Dale. So that's going to be a tough act to follow. Alice was very interesting and forward-looking approach to open data. Unfortunately, I guess up here in British Columbia, Canada, we're a little bit behind in releasing data and having data open to the public, but we're from crime data anyways, but we're moving in that direction now at a good pace. There's been several initiatives throughout British Columbia and to some into Canada where more and more police agencies are starting to open up their data. So I'm going to talk a little bit off the bat about some of the challenges in releasing crime data to the public from sort of a type of crime perspective and also from a privacy perspective. And then I'll talk a little bit about what we're actually doing here in the RCMP in BC with regards to releasing crime data, how we're doing that, and kind of where we're going with it. So really the big issues facing us was what, is how do we deal with the privacy of individuals when we release crime. So if I pop over here, this is an example of some property crime data in the city. And so you can see that it's mapped out more or less to where the particular crime happened, right? So in order to provide some privacy to the individuals, we like to try to anonymize our data so that it doesn't exactly show where exactly that crime happened, right? So we use FME to do that process. So we go from what we saw with those green dots to the red. Now, it's not a huge change in some cases. If I flick back, you can see some of the points stay the same. But if we're focusing in on some of these areas here, you see that the points are getting remapped to the center point. Now, that works out pretty good in an urban environment. You can see with the property boundaries that I have on here that there's a fairly high density of individuals in this area. But if you head out to a rural area, that's less apparent. You have properties where there's only maybe one or two houses out there, and so when you start releasing or displaying crime data for these areas, it can be very easy for people to figure out where these crimes happened. So here at the RCMP, what we're doing is the release of crime data at this point sort of falls to our local detachments. My work within the RCMP is to support the detachments in their ability to try and do this type of work. So we piloted property crime release within the Nanaimo detachment. They were fairly forward thinking about getting their data out to the city of Nanaimo. So I'm going to hop around a little bit on this. So just so we could, I can show off our little bit of FME. My caveat is that I didn't actually write this FME script, although the process, the methodology was something I worked with my technologists. We do sort of a similar process where we don't unfortunately connect directly to a database. We have an analyst at the detachment who goes to our data warehouse of all of our records data and pulls off the crimes that they want to have made available to the city of Nanaimo. So they send us this table of crime data for usually 1 week period. Every week we get this. So we pipe it through our FME script here, do some data to do some reformatting of some of the data and to anonymize it to the mid block. So if I zoom in a little bit, sort of get to the meat of the script, the first, we need to deal with our date fields and get them into sort of a normal format, because they're stored in sort of an aggregated hours, and the data and the hour all in one big field. So we break that out into something that could be consumed a little bit easier into a database. But then we take that information, we take the addresses, we replace the last two numbers in the street address with X's, and we remap all of those data points to the center block or the nearest intersection of the street data. So we do that down here with using a neighbor finder. It moves the point to the closest of the same block. And one of the challenges we had here is we had a lot of the points would remap to a different street, because they were actually spatially closer to the midpoint of a different street than they were the street they were actually on. So the FME script is we look at the actual street data and the actual street name that's in that data point, and make sure that whatever point it's mapping to has the same matching name. So moving forward with where this all ends up landing at the end is to a crime map like this. So for us, what we're trying to do is we're trying to empower our detachments and their relationships and their partnerships with their municipalities to provide this crime data out to the public within their particular jurisdictions. So this data, once anonymized, is sent to the City of Nanaimo, and they place it onto this crime map. So what the City of Nanaimo provides is the ability to zoom in, get closer looks at these points, and they can download the data in a couple different formats. So this is really one of our first at the RCMP's initiatives to start to I guess I should term be to formally or release data out to the public on demand. So there's a couple other examples in British Columbia. There's a number of different police agencies, both RCMP and municipal forces, that are providing crime maps, and so I'm not picking anyone out to exclude the others. They're all meeting their needs. The Vancouver Police Department have a application called Geodash, which is something similar. It's much more map-centric than a lot of our applications. So this is a map showing the property crime that's currently occurring in my neighborhood in Vancouver. So for the past, I think, 4 weeks. So that looks on par for where I live. For the RCMP, as we move forward, we'll be looking at there's initiatives here to actually start releasing data nationally, right? And so this is a fairly big project, but in our research of how best to do this, what I thought was a particularly good example of outreach of providing police data and information out to the public is the police.uk site, which is showing policing in England, Wales, and Northern Ireland. What's nice about it is you can do a search for find your neighborhood, and when you go and find your neighborhood, in this case I looked for London, I think, yeah, City of London, you're presented up front with this really nice big map, right, where you can drill down into the different crimes. Again, there has been an amount of anonymization to this data as well. It hasn't actually been mapped in the exact location, some clusterings. But as well, you can actually look at more than just the crimes that are happening. They have additional information about the policing team and news and events. It's a very integrated solution, which really opens up the police agency to the public, and kind of gives it more of a friendly and accessible feel to it. So moving forward with the RCMP, at least with the RCMP in BC, now that we have some anonymization releases of data going on, for us it's still kind of a manual process. But we're going to be moving into a much more automated system where we'll be accessing our databases directly, just the way that Alice does at Auburn, and then pushing that data out to either enterprise data services like REST endpoints or that can be consumed by applications, and also to FTP sites where the local detachments can reach out and get the data that they want when they want it, and then distribute it as they see fit according to their relationship with their partners. And so that's what the RCMP is up to with open data so far, at least the RCMP in BC.
That's fantastic. You know, I remember in 2008, Nanaimo got kudos from Google back then, saying that they were the most advanced in their mapping technology city in North America and this sort of thing. And there was actually a long time, really early adopter guy who's now a manager in Nanaimo, Jason Birch, who was a key figure in that. And here they are today as still kind of leading and pushing the edge in Canada in a totally different area. But thanks so much, Robert. So we'll go to some questions and answers. While people are thinking about writing something in, at the moment, the publishing this isn't being done with any kind of commercial data portal. This is like this crime map is done with what technology? It just looks like a Google map, basically.
Yeah, I think it looks like just a little Google JavaScript API. They're using Google for the base, and then they're hitting a database at the City of Nanaimo to actually display the data. From what I understand, it's a fairly automated process on the analyst side. After the analyst sends me the table, I anonymize it, I send it back to them. They just have an upload portal that sends it up to the database. Obviously, Nanaimo will be able to comment further on that.
Yeah.
I also know that this was their first crack, so you're looking kind of like, I would say, at version 0.1 of their crime map. And there is I know with talking with them in the past that they do plan to integrate this more in with their actual corporate main city GIS map, which is a little more sophisticated.
So in the work that you've done, the primary purpose is around anonymizing, basically shifting things around. Are you doing any data quality tests in there at the same time, or is that kind of meant to be done in the front end?
It's mostly done in the front end. We're only releasing property crime data right now. Again, in my research so far, it's a bit all over the board on that. Some people release, some agencies do release crimes against the person. I know that the VPD's application does that as well. If you read the disclaimer, it says that they anonymize the crimes against the person, by randomly remapping it, several blocks away and then sticking it on an intersection. So, with that in mind, you could say, well, this particular crime against a person could have happened, anywhere within, they always say several blocks. So they don't say if they do it 5 blocks or 10 blocks. So that does give a greater degree. But it's also the feeling that because these crimes against a person tend to be fairly high profile and end up in the news more often than not, that would just have that mapped and made, known, have that mapped would become sort of too much of a infringe on people's privacies, right, and sensitivities towards what's happened to them and to their neighbors.
Yeah.
So from a QA perspective, most of that's what gets pulled off of the database right now is done by the analysts, and they basically focus just on the crime, founded, what we call founded, or founded or unsubstantiated files. So these are files that either it was founded that property crime occurred, or that even though it was reported, it wasn't substantiated either. They said if your car was, your wallet was taken, but they couldn't, say for sure who did it or something to that effect. Things, unfounded case calls where there is no evidence that something happened aren't included, even though that's part of our record system.
Right. So Greg asks, do rural detachment commanders get training in creating and interpreting these data sets?
Detachment commanders get advice from our analytical teams is how it tends to work. So we're just coming at the front end of this. So again, here the RCMP. So things like policy on what can be released and information to the detachment commanders on how to take this data and how to release it, and so that they're successful with it is sort of all still forthcoming. But our RCMPC, we have an analytical team some detachments have their own analysts who would be providing the interpretation and advice to detachment commanders on, what this data would mean. For detachments without analysts, we have district analysts who provide services to those detachment commanders who do the same sort of work.
Right. Yeah. And I know, there was just recently an article that I was forwarded about, although Dallas has had great success, there was some data quality issues resulted in some stuff getting released that was not good. It was revealing people's names and addresses and things. And I think that comes down to data quality types of issues in the front end. And so I think that obviously, as the tighter the systems can be made to kind of prevent errors early in the data, and then having some checks and balances further down the pipe, I think are very important.
Yeah, I agree with that as well. We also don't release a lot of information, really. I mean, and I flipped over to the next page on City of Nanaimo here, and it gives a list of the types of crimes we are actually releasing for Nanaimo, which are all property-oriented crimes. But then each of those records only includes the actual locations. So that would be the remapped X and Y to the midpoint of the road, the crime type, when it was reported in the file number, right? So just these fields get pulled off. So at the point where the analyst is pulling the data off, they're only grabbing certain fields of the entire data set, which is not the whole thing. Where an automated process would do something similar, be probably quite narrow in focus, at least initially.
Right. And so, for example, you would stay far away from any data fields that had the word name in them.
Yeah,
so,
exactly.
And I was even thinking that you could imagine one of the issues that I think maybe happened in Dallas is that some information was put into the wrong field. And so, an FME-centric solution, but it could be any solution, would be just to say, okay, just before we're going to actually publish this, let's do a search for blacklist words in anything in any part of the record. So, if the word assault was actually still in there and we didn't expect it, we'd get rid of that. And you could imagine hitting like a names database just to make sure that no name is actually loose anywhere in there, and at least flagging such records.
Yeah, and for the feeding of our record system, there's a lot of when a file is created and an officer interacts with that file, provides the information from their investigation, that sort of work. Those files all get from the officer to a supervisor who reviews it.
Right.
And once the supervisor reviews it, there's a whole records section of people who go through and do quality checks on everything before things get concluded, right? So there are a number of steps at front end before it gets out. Not to say that there aren't going to be errors. I think it might be a little naive to think that we could eliminate all errors from our data. But I think what's more important is that we realize that we could have some errors in it, and that when we're looking at data, we need to look at data as sort of a whole, is what it's showing us, as opposed to that one record that may be not correct.
Yeah. Excellent. Well, thanks very much, Robert, and please hang on the line in case more questions come in by the end. But I think with that, Kat, were you just going to finish up today by just telling us a couple of things that of some of the customers you've worked with?
Yes, absolutely. During our FME World Tour earlier this year, a couple of our customers had some great presentations talking about open data within their cities and how it was used. So I'm just going to quickly talk about that.
Good. So these are not necessarily about crime, but just in general open data, although the same techniques and lessons would apply.
Absolutely, absolutely. So both the cities I'm going to cover do have open data, and so we'll start off with San Francisco. So open data is no small task in the city and county of San Francisco. I don't know if many people know that, but it's actually the city and the county are merged in one. Launched in 2009, the SF Open Data Portal contains hundreds of city data sets for use by developers, analysts, residents, and more. So one of the strategies San Francisco had to achieve their goal of increasing the number and the timeliness of the data sets that are made available on their Open Data Portal was to develop their program to automate the publication of data. So why automate? Data is most valuable when it's timely and recent, but manually updating data is time-consuming, resource-intensive, and prone to error. We don't want that error in there. And as a result, they prefer automation and provide a set of services to help automate the publication of data. So towards this, their open data team have actually designed and deployed an ETL job platform, which allows their technical staff and their data stewards to automate their publishing while ensuring high quality data. It's been rigorously reviewed, and it has the appropriate transformations, quality checks, and notifications applied to it. So they limit the number of authors they have, so the people who do author these automation tools are very good at their jobs. They have a separate testing environment to make sure that everything is working out, is been reviewed, has had the data stewards and the technicians look it over and make sure it's absolutely the best data they can get. They use best practices and are therefore able to get up to 500 ETL jobs. So, these are 500 jobs that are automating the publication of their data to the open data.
And they're running like all the time, basically.
All the time. And so
okay.
their open data platform has, things that are updated daily, these things are updated yearly. So, one of those 500 jobs only gets updated once a year. But
right.
it's automated, so, you don't have to remember what
right.
you did.
Right.
So some of these goals were achieved with central automation by adding additional benefits like automatic geocoding. So, each department has their own access database hidden away somewhere, but they can then automatically geocode those and get well-formed addresses or consistent lots and lots. And so you can get really good point-based maps. I'm going to say this horribly wrong. Automated geo-obfuscation.
Oh, geo-obfuscation.
Yeah, there you go.
That's a new term.
That's a new term, right?
Anonymization. Even saying that confused people.
Yeah,
but
so
obfuscation.
Yeah, so if you don't want your addresses available for privacy reasons, the data can be assigned to another level of geography. So it can be street census, census block, or tract, neighborhood, or even the supervisor district. So they can pick the level of where you want your data to actually show up.
So what they've done is build a central best practice repository of these kinds of techniques, and they can apply them to each data set.
Absolutely. And then they also have automatic geo-assignment. So similar to above, you can use an address to assign it to a geographic boundary and then add new data, like columns, like supervisor districts and neighborhoods, to data that doesn't already have it. So the results, an enterprise-level effort to automate the publication of San Francisco's data to an open data portal, and a whole bunch of ideas of what they want to do in the future. So this was definitely going to be round one. They have a lot of ideas on how this automation is going to be taken to the next level in future iterations.
So if anybody wants to check the original presentation out, it has a lot more detail in it. The links will be available afterwards, and you can see what Samuel and Janine had to say in San Francisco a few weeks ago.
In San Francisco, yeah. I
So
think you were at that one.
I was at that one. It was great.
Good. I hope I covered their their story as well as they did.
You did a fine job. They went into a lot more detail, of course. But
yes.
They're really at kind of an enterprise level of making these things very rigorous and repeatable.
And they're really keen on having this stuff available. So their entire data automation process is available on their website to share with everyone who wants to know how they do it or how their different departments get involved in doing the open data and the sharing.
So Alice could take a peek at it.
Alice could take a peek at it, see what their best practices are and what's available, and that's part of their open data policy is to share that with everyone.
Yeah, the techniques actually.
Yeah, actually.
So everybody can obfuscate.
I'm never going to be able to say that word.
Yes. So now we're going to go to the other coast.
The other coast, yeah, as far away as you can get. So open data in New York City. The New York City Open Data makes a wealth of public data generated by various New York City agencies and other city organizations available for use for the public. We're talking thousands of data sets at this point. As part of an initiative to improve the accessibility, transparency, and accountability of city government, this catalog offers access to a repository of government-produced machine-readable data sets. And that's one of the key things that I think about open data. Yeah. It's not just that it's available for everyone. People actually use the data and take advantage of it in automated ways.
Yes.
Slide monkey. Sorry. So the citywide street Centerline database is the authoritative source for all location data used by New York City's 911 dispatchers. But to send people to where they're supposed to go, they use this one database. It's an Esri enterprise geodatabase that is jointly maintained by 2 city agencies, the Department of Information Technology and Telecommunications and the Department of City Planning. It is also governed by an additional 5 city agencies.
Wow.
So there's 7 agencies involved in total, including the NYPD and the New York Fire. So this database includes addresses, streets, intersections, common places. So if you said Empire State Building, this is where the database would keep it. But when they designed this database, they designed it so it would be really good for maintenance, keeping the data up to date, and is highly architected. So unfortunately, that results in a data model that is scary beyond belief.
Oh, really?
I definitely recommend you checking out the slide deck afterwards, because the data model is actually a terrifying thing. But just for example, they have 68 feature classes, 40 tables, 47 relationship classes, 2 feature data sets, 8 topology rules, 93 domains, and 2 subtypes.
Yikes.
So not exactly accessible by an average GIS user, let alone a member of the public.
Right.
So with a bunch of work using an, sorry, can you switch slides?
Okay.
Thank you. So with a bunch of work, they created a new version that they made available on their open data, and actually both their city staff and the public use this. So while the original database is the main source of authoritative data, the database that they've created for open data is actually used by the majority of their staff.
So basically, they've got a simplified view of that very complex data model that a mere mortal or it looks like Batman.
Yes. So as for Batman, to paraphrase Chris Rado, and he's the GIS manager for the Department of Telecommunications or Information Technology and Telecommunications, and the guy who presented this in Washington. As he tells me, Batman, he's just another member of the public who can access New York City open data.
Okay. Along with Daredevil and everybody else.
Yeah.
Anyway, that's awesome. I mean, those are just 2 examples. Kat, in your work with local government, how many clients are you, like, can you take a wild guess? You must have dozens, hundreds doing this kind of stuff?
I can't even take a wild guess.
Yeah.
Yeah, I think if I talk to a local government, they talk about open data.
Right.
Right. It is a huge, huge thing, especially down in the States. But even so in Canada, is getting those databases out there and having people have access to them.
And the sets of challenges are very common. So if it's obfuscation, anonymizing, automating, quality testing, simplifying data models, dumbing it down.
Being the authoritative data set.
Yeah.
You know, what do you do to make sure that you have all the right information?
Providing it in different formats, getting it to some sort of publishing framework. These are the common scenarios we see all the time. So I think with that, does anybody out there have any questions for us? Tony asks, what viewer are we using? I'm not sure. In terms of these, Tony, if you can provide some more detail. I mean, this is actually Google PowerPoint. That's what Google, whatever his presentations. In the case of Robert, he was using, or the Nanaimo folks were using just a Google map with some stuff on it. In terms of our own customer base, we see people doing stuff with ArcGIS Online very often.
So New York City Open Data is a Socrata site.
Oh, okay. Yes. And yeah, that's right. So they would be using that whole framework as well.
Yes. Yeah. So yeah, the Socrata map is the Open Data Web Map is for New York City is Socrata.
Yeah, and actually, Rogers shared a story with me about how that open data. One of the things in the New York Open Data was where people get parking tickets.
Right.
And it resulted in a citizens' initiative because they realized they were clustered in some certain areas where the signage was confusing.
Yes.
And so. While I guess it might not have been in the interest of the city, it certainly was in the interest of the citizens, and it resulted in the city improving the signage in some of these high parking ticket areas.
And $1 million of tickets no longer being issued. Millions.
Yeah, so that money came from somewhere. I guess it's back in the economy being spent on pizzas and things.
Yeah.
But yeah, so that's just one example. Yeah, and so I think in terms of the web map, as far as we know for New York, it is also through the Socrata.
Yeah, I believe so, yeah.
So Does anybody else? We're just about at the end here. If there's any other questions, continue to send them in. But I'll just begin the wrap-up part of this, and that is just to remind folks that if you liked or you're interested in what you saw today, we're going to be following up with links to all these things on this slide. But in particular, I think that the blog post we did about a year ago on open data, which was a survey of a number of different tools for creating that. You can certainly take a look at that. We did a webinar about a year ago where we dug in and looked at a number of these in more detail. These were more about data publishing things. They weren't really about the back end, about how you actually, what you might want to be doing to prep the data. We have an ebook for that. If some of you are interested in learning more about FME, all of our training is free, and so you can take part in either of those sessions, and again, we'll send you links to that. And the slides that we're showing today, we will have links to or a link to that, so you can look through, and those in turn will have links to the presentations that have more detail from, for example, the ones that Kat just presented as well.
Yeah.
So I think with that, let me just see, is there any other questions that we should address? Otherwise, I think we'll...
Look at us finishing early.
Yes, we're prompt and on time, but I especially want to thank both Alice and Robert. Thank you so much for sharing your experiences with us today.
Yeah, my pleasure.
Yep.
Yeah, it's always, at SAFE actually, what really makes us wake up in the morning and come to work is to see that the tools we make can help make a difference in the world in general. And I think the work you're doing, we're just happy that we're able to help you do that work a little more quickly than you might have otherwise, because I think it's very, very important work. And to all of you tuning in, thanks so much for spending an hour with us. We hope you found this interesting. We hope you found it seeding some ideas and planting some thoughts as to how you might apply some of the techniques seen today to help you and the work you do to serve your communities better as well. So I think with that, I'm going to say goodbye from Surrey. So goodbye.
Goodbye.
And thank you so much.